Yeah, I think...
I can't hear you.
Now, probably because of this rebuilding, I'm not sure what you will find, because they are moving things out. It will be sort of closed for a few months, the lab, so I'm not sure if there's anything funny to look at. Probably in this other lab, which we do the turbo testing, that's still running, so there we can see something. But anyhow, this is this Anechoic room, as I guess most of you seen maybe before, these type of rooms. It's a quiet room. And obviously, I mean, in these rooms, I mean, what you do typically, classically, is that you measure sort of the directivity. You put the source here and then you measure how sound goes out in different directions. But what you also can do here is to open these behind you. You have doors, and if you open these, well, you see these cassettes with these absorbers, but you can remove them and open these doors. And then you can mount, you will see it on the other side. You can mount things in an opening, and then you can have transmission measurements between this room and the other room. And then you can measure on panels, let's say roof panels, or something from an aircraft or a car. I mean, so you can measure the sound reduction of materials or structures. And the last thing we do here, besides measuring on sources, testing panels, is to, if you look on the corners here, you have these slits. And that's connected to fan system downstairs. So if you start the fan, you will get air coming into these slits, and then you pressurize this room. And then if you close everything, and of course if you have an opening somewhere, you get the flow. So typically what we do is that either downstairs, you don't see it, but in that corner of the room there is pipes connected, so you can get flow from this pressurized room into those pipes. And then they contract, so you can make tests inside pipes for mufflers or whatever you want. And you can also, if you will see on the other side, put the pipes behind these things here and get it flow into the next room. That's also possible, actually. So that's sort of, I think, what is unusual with this room, that it's sort of partly part of a flow test rig. I mean, normally you use it for purely acoustics, but this is also used for some flow acoustic tests, which is a little bit unusual.
What's the highest flow?
We can have a fan. The fan is up to 10,000 pascals. So if you just use Bernoulli, that makes like 150 meters per second maximum. And the maximum flow rate we can have is 10 cubic meters per second. Okay. So it's quite good for the test we are doing. I mean, in ducts up to maybe 30 centimeters, and flow speeds, well, up to maybe typically 100 maximum, because I mean 150 you have no pressure drop against the fan. So typically when you load it for something you get of course less. So between 50 and 100 is normally what we can do when we have the tests. And that's, I think that's enough for, I mean, if you talk about silencers for cars or for ventilation or many applications, that's enough actually. And of course it's a cold flow, it's no heating. But that's not really, I think, so critical, because if you just use scaling, I mean, yeah, you can still measure at cold air temperature and then rescale the frequency scale to sort of see what it will look like at higher temperatures. I mean, the only limitation in that is that the viscosity doesn't really scale in the same way as this acoustic speed of sound. But I mean, the purely acoustic effects you can scale the frequency. So that's not a big problem. But losses would be slightly different, of course.
What's the back